Okay, what I'd like to do is just an example of taking a derivative and simplifying it. We made this problem a lot harder by not simplifying the derivative and trying to just set it equal to 0 right away. So what I'd like to do is just take the derivative, simplify it, and then show you how setting it equal to 0 and finding it when it's undefined is a lot easier that way. So the problem I'm going to do is where we're looking at 5x to the 0.3 times 100 minus x to the 0.8. So I'm going to go over to my little whiteboard, and hopefully I can scratch my way through it. Here we go. Okay, all I want to do is take the derivative. So I'm going to write down derivative equals, and I'm going to need the whole board, right? I need to use a product rule, so this is going to be what? 1.5 x to the minus 0.7, like that. I guess we can put parentheses. And then I need 100 minus x to the 0.8, and we're using the product rule. So what I'm going to do now is to take the derivative of the second part, which is going to be 0.8 times 100 minus x to the minus 0.2. Let's not forget the minus 1 that comes from the chain rule, and then I still have my 5x to the 0.3. Just made it. All right, now what do we want to do? We just want to look at this first thing here and this second thing here and take out what they have in common. That's it. That's all you have to do for most simplifying things, and it carries you just about all the way through. Now, I'm not going to worry about the numbers. I'm just going to worry about the terms that have x's in them. For example, both terms have an x to a power, and you always take out the lowest power that you see. You've been doing that since 11th grade, but now it just feels weird. The lowest power that I see is to the minus 0.7, so that's actually what I'm going to have to take out. Now they both have a 100 minus x to a power, and I'm going to take out the lowest power of that I see. So I'm going to take out 100 minus x, like that, to the minus 0.2, just like that. Yay! Now what I want is what's left over. And remember, pulling out just means divided by. So what I want to do is take this whole term here, divide by this stuff, and see what's left. Well, let's see here. The 1.5 is automatically left because I didn't do anything with the coefficients, so the 1.5 is still there. The x to the minus 0.7 divided by the x to the minus 0.7, that's just 1, so I'm not going to worry about that. The 100 minus x to the 0.8 divided by 100 minus x to the minus 0.2 is rules of exponents. If this doesn't seem obvious to you, you need to go work on your rules of exponents, because you shouldn't have to write this all out every time. And I don't expect it, but I do expect it to get it right. Remember, when we have a base to a power on top and the same base to a power on bottom, we subtract exponents. So this is going to be 100 minus x to the 0.8 minus a minus 0.2, like that. This is 100 minus x. 0.8 to the minus 0.2 is 1. So that's just 100 minus x. This is the way it usually works when you take out derivatives. This is why we do stuff the way we do it, right? So here I'm just going to get 100 minus x, like that. And we've now taken the common term out of the first blob. There is a second blob, the plus sign's still here. I go like this. Now the constant's still there. 0.8 times 5 is 4. So I'll do that. 100 minus x to the minus 0.2 divided by 100 minus x to the minus 0.2, that's just 1. That's fine. The minus 1 is still there. What do we have here? I have x to the 0.3 divided by x to the minus 0.7. Well, that works out the same way it did before. This is just x. This is where your algebra really has to help you. Now, what I'm going to do is rewrite this as a fraction. The x to the minus 0.7 goes on the bottom. Now, by the way, this function was defined at 0, but the derivative is not, which means there's some sort of corner or vertical tangent line there. That does mean that x equals 0 is one of the critical points that needs to go on our number line. The 100 minus x to the minus 0.2 also goes on bottom. Meaning our original function was defined at 100, but our derivative is not, which means actually that x equals 100 is also one of the critical points that we're actually frequently leaving off. Now what I want to do is just see what numbers I have here. I'm going to see if I can get this right this time. 1.5 times 100 is just 150. like that, right? And I have minus 1.5x minus 4x. This is minus 5.5x, like this, like that. Now, if someone hands us this and says, find the critical point, this is the derivative, right? What are we supposed to do? We set the bottom equal to 0 to find out when the derivative is undefined. We set the top equal to 0 to find out when the derivative is equal to 0. You set the top equal to 0, and you get what we all got, yes, which was 311ths, but I think you had to work a lot harder than this. And you also missed these two values. These are critical values that are supposed to go on the number line. We're not done yet, right? We'd have to make a sign chart or a table. Either's fine, but this is the way you need to be simplifying the derivatives. It's straightforward, it strengthens your algebra, and it usually works this nice. So don't kill yourselves, simplify the derivatives.